There is a widespread assumption that getting an API key for the smartest language model is the same thing as building an AI product. It is easy to look at that raw power and assume the hard work is finished. But a model on its own is raw intelligence. Think of it like hiring a brilliant graduate student who has no access to your company's software, cannot hold a pen, and forgets everything you told them yesterday the moment they go to sleep. To make that model useful, you have to wrap it in a framework layer. This is the connective tissue that turns a chatbot into an autonomous worker. This layer provides the tools, like the ability to execute code or query your databases. It manages long-term memory so the agent knows what happened last week, and provides the orchestration logic so multiple agents can hand off tasks. Because models need these integrations to perform tasks, $1 spent on an API often creates $5 to $20 of value only once it is inside a framework. This layer is the lever that makes the model useful in a business environment. Developers have to choose how to build this connective tissue. The market has split into 3 distinct philosophies that require different engineering decisions and long-term commitments. You have OpenClaw, which prioritizes composability, MaxClaw, built on opinionation, and NemoClaw, which focuses on locality. Choosing the wrong one for your project is an expensive mistake. It can lead to a dead end, whether that is technical debt from maintaining custom code, failing a compliance audit, or building an app with bad latency. Evaluating these frameworks is about accurately mapping your specific business constraints to the right architectural philosophy. This table breaks down the 3 approaches, starting with OpenClaw. This is the open source flagship, and its philosophy is composability. In practice, that means every component is replaceable. If you don't like the default memory system, you can swap it for your own vector database. If your team needs custom tool execution logic, you can rewrite it from scratch. The cost of that freedom is time. You need a dedicated engineering team to assemble these modules and make foundational decisions about how the architecture should fit together. This upfront effort provides absolute control. You own the stack and avoid being locked into a single vendor's roadmap as the technology evolves. However, the initial learning curve is steep. Teams often find themselves spending energy maintaining infrastructure and wiring up new modules instead of shipping product features to their users. OpenClaw is a toolkit to assemble. You are trading initial setup speed for long-term technical sovereignty. The second row shows MaxClaw. This is the enterprise-grade, closed-source alternative built on strict opinionation. Opinionation means the vendor has already made the hard architectural decisions for you. The memory schemas and the orchestration logic are battle-tested and locked down. You do not change them. Accessing this system requires capital. Deployments start in the tens of thousands of dollars and can scale into the millions for large organizations. That premium buys you immediate operational maturity. You get guaranteed SLAs, support teams that pick up the phone at 3 in the morning, and out-of-the-box compliance certifications like SOC 2 and HIPAA. The major trade-off is lock-in. Because the orchestration patterns and integration points are proprietary, migrating away from MaxClaw once you are in production is difficult. A MaxClaw contract offshores your compliance risk and guarantees reliability in exchange for a predictable, high-tier subscription cost. Finally, the bottom row covers NemoClaw. This framework competes on a different axis, physical location. The fundamental architectural philosophy here is locality. NemoClaw is designed to run the agent entirely offline, directly on consumer hardware, like a smartphone, a laptop, or an embedded system in a robot. Running locally provides a user experience advantage. You get 0 network latency, immediate responses, and data privacy because sensitive information never leaves the device to hit a cloud API. The constraint is the hardware itself. Phones and laptops require smaller, quantized models. These models are fast, but they have a lower capacity for complex reasoning tasks than their cloud-hosted counterparts. In practice, this often leads to a hybrid architecture. The local agent handles the fast, sensitive tasks, but it delegates heavy reasoning workloads back to the cloud when needed. NemoClaw requires a sacrifice of raw compute power in exchange for an agent that is private and instantly responsive. Because these frameworks are specialists, deciding between them comes down to a filtering process based on your project's constraints. This flowchart maps out the decision. First, Does your deployment target run in the cloud or on a local device? If it must operate offline with zero latency, take the local path to NemoClaw. If deploying to the cloud, the next filter is your regulatory environment. Are you facing strict compliance requirements, or is the project unregulated? If in healthcare or finance, take the strict compliance path to MaxClaw. Bypassing a security audit justifies the enterprise cost. For unregulated cloud projects, the final filter is timeline versus control. Do you need a quick turnkey solution or a long-term custom platform? If building a long-term platform, route to OpenClaw. The initial friction pays off through compounding flexibility. Following this specific map protects your engineering teams from choosing a tool that constantly fights their ultimate business reality. If your team is starting today and you are still unsure of your final scale or target market, you can default to OpenClaw. It requires initial assembly, but its open nature ensures you will not hit an expensive dead end if product requirements pivot 6 months from now. Ultimately, all three are capable. The most significant mistake in this cycle is getting paralyzed by analysis and failing to ship a product to production. The advantage in this market lies with the architects who master the connective tissue required to put these models into actual production.